Welcome to another video from Lockdown Electronics with me, Bill. Now, a few videos back I looked at the LM3914 bar graph display driver chip, a relic of the past now, I recognise, and at the time I'd got lots and lots of example circuits that I actually would have liked to include in that video. It would have made it far too long, so I decided I'd at some point do a bit of a follow-up, and that's what you've got today. So we're going to look at two uses for the display driver, one which I actually think is genuinely practical and would be useful, and another one which is probably less practical but novel, shall we say that. Anyway, let's start by having a look at the first circuit. Okay, first circuit then in the 3914 series is what I'm calling a battery monitor. This is the circuit. Now, if you search the internet, you'll find hundreds of examples of this everywhere, and it's based very much on what you can find in the 3914 data sheet, so there's nothing terribly exciting here, except to say that pin 9 I've attached to positive, which sets it into bar graph mode rather than dot mode. I think that works better in this application. And the other thing to note, which is sort of obvious but perhaps isn't so obvious, is that there's no power supply. That's because it doesn't need one. It uses the battery it's testing as its power supply, obviously, but that's still nonetheless, I think, rather nice. So providing your battery is between the voltage range, you're going to get a result, as we'll see in a minute. Now, I've set it up on the breadboard, and I've adjusted the 10k potentiometer such that the first green LED lights with about 12.7 volts, something like that. So here's the layout on the breadboard. I'm just showing you that because it's harder to see the colours on the video than it is here, but we've got 4 red, 2 yellow, 4 green. Right, let's go and have a look at that on the bench. Here's the circuit laid out on the breadboard then, and apologies for the slightly dimmer light, and I want you to be able to see the LEDs, although that will still be a bit of a challenge. So got a chip here, obviously that's the trim pot, exactly as the description just now on the slides. So currently I've got voltage coming in here, and we'll actually look at that voltage on a multimeter, which you can see there. Currently it's at 9.03 volts, and I'm just going to use the adjustment on the power supply to turn the voltage up. Now, I've already set this so that the first green LED there comes on at about 13.7 volts. So let's slowly increase the voltage, and there we go. So the first red LED is lit at about 9.84, you can see. So if I continue now to increase the voltage, and so we've got 4 red LEDs on now, and although it's not particularly easy to see, the next 2 LEDs are yellow and they come on like so. Second yellow LED lights at about 12.2. I do accept that looks ever so slightly green, but I assure you it is meant to be in the yellow LED. And the first green LED just burst into life there at about 12.7. So if we carry on up until we get all 4 LEDs up there at about 14 volts. Now, most lead acid batteries rarely get that high unless they're actually on charge, so to speak. So yeah, drop it back down. It's off completely at about 9.5 volts, but by the time we get above 9.5 it starts to trigger, and if I come up slowly again, there's the second yellow. First green comes on about, as closely as I can get with the adjustment here, around about 12.7 volts. Now, I set that using the pot, didn't think you needed to see that, but as you see, the simplicity of this circuit, of course, is that it doesn't need a power supply as such. It just works with the voltage that's been input, and I think that's quite a nice little use for the for this chip. It does a nice little job of showing you the charge state of your battery, and it's always going to work, because if your battery's got any charge at all, certainly in the range, you're going to get a result. There's no hunting ground for a a set of batteries to replace on the meter. So okay, that's the 3914 used as a 12 volt battery indicator. Okay, so the next project is taken from the annals of 99 IC projects, the 1982 edition, and again I've got this from the World Radio TV website. That's rather excellent. You've heard me mention it before, and this is a bit of a novel use for a 3914. That's why I picked it for inclusion here. Back in the 80s and also the early 90s, it was possible to obtain cheap and cheerful antenna rotators a bit like this. They were designed to move your television aerial if you were somewhere where you could tune to a couple of different masts. These appear to have completely vanished now. Probably says more about the availability of online video rather than the fact that the rotators were good or bad. But I used one of these with VHF and UHF antenna. It's more than capable of doing that. Wouldn't support an enormous weight, but certainly it was a great deal cheaper than some of the offerings from the mainstream manufacturers. Now it did have a control box, and that control box sort of tells you where it was heading, and it was alright most of the time, but it could get out of synchro because both had a motor, and it relied on the motors running perfectly in synchro with each other, so you sometimes had to rotate it to both ends and wait a couple of minutes while it did that. But if you were too impatient to put up with that, there was a solution here in the shape of this circuit, which uses a potentiometer attached to the antenna shaft with a pulley, as you can see bottom right, and essentially what it does, it means the position of the shaft on the rotator would give you a variable resistance, which is clearly based on the position that the shaft is actually in, or the direction it's pointing. Obviously there's some issues here with about weatherproofing things, but hey, you know, if you were keen you could do this. I really picked it because it was a novel use rather than because of its practicality. So here's a close-up of the circuit, nothing too exciting. Again, if you look in the data sheet for the chip, you'll see very similar circuits. R1 is 25k pot. I'm afraid I don't have a 25k pot. I've only got to nearest I've got 10k, so it doesn't work 100% like it might. The first LED does actually go out. I think it would work better with a 25k pot, but hey, there you go. It demonstrates the point nonetheless. So looking at that on the breadboard, yep, looks a bit of a mess with all those jumper wires. I've done that in an attempt to put the LEDs in something that roughly resembles a circle, not quite perhaps, but almost, and they are yellow LEDs, despite the fact that one that's lit looks a bit green. It is a yellow one, or it certainly has a yellow encapsulation. And the pot, you rotate it and hopefully the LEDs will show you the position. Okay, let's go and have a look at that on the bench. Here's the circuit then on the breadboard, and as I said previously, it's a bit of a dog's breakfast in a way. It would be obviously an easy thing to implement on a printed circuit board, not quite so easy on a breadboard. So I've done my best to arrange these LEDs in a circle. It's not quite right, and as I've already mentioned, I don't have a 25k pot, so I'm using a 10k, which is about the nearest here, and currently we've got that LED lit and the pot is roughly at 50%, something like that. So if I wind it down, you can see we do indeed get a display moving down to there. And then if I carry on up past the halfway point there, we do indeed get the display climbing up to the top. So yes, that would indeed display the heading. So if that was if there was an arrow on top of here, currently it would be sort of pointing that way, and as hard to show you, but as we swing round like that, so we do indeed get a relative heading indication. So yeah, it would work on one of those cheap rotators. Again, you know, we're pointing to the right there, and as we come round to the bottom there, yeah, and then eventually right round to the right again. Those rotators didn't quite do 360 degrees anyway. They did stop. So yeah, that would actually work as a heading. And if you've got a beam, say a 5 element 2 meter beam, something like that, 5 or a 7 element, the difference between one LED and another wouldn't be enormous in terms of signal strength. You could probably hear it just to tweak it a bit, but at least you have an idea which way your antenna was pointing anyway. So there you go, a novel use for the LM3914. Right, well there you are, two uses for the LM3914. As I said, one that was I think quite practical, the battery condition indicator, genuinely useful project. Not quite so sure about the antenna bearing indicator, but it would have worked. Whether it was actually worth all the trouble, there's probably better ways to do it, but it was novel, I thought, and hence worth including. So hope you've found it interesting. Thanks very much indeed for watching. As ever, please comment, like and all that stuff, and I look forward to seeing you on the next video.